Perfect. Okay, welcome everybody. Welcome back. Now we're going to cover section 3.2, measures of variation. So in 3.1, we learned how to calculate different types of central tendency, like the mean, the median, the mode. And so that if you remember, how do you calculate the mean of some data? Well, you sum up all the values in your data table, and then you divide by the number of data points. So we're going to start off by doing some calculations of measure of variation, but let's just calculate the mean for this example of brand A. So what they're doing here is that there's a lab that's testing two different types of paint, and they're trying to see how long does it take before these 6-gallon cans of paint, when you put them on some type of wall, does it start to fade. And so here, we have brand A. Looks like it has one sample, only took 10 months, which I'd be very upset about if my paint faded in 10 months. The next one took 60 months. What's that, 5 years? The next one's 50, 30, 40, and 20. Okay, so the mean for that brand A then would be 10 plus 60 plus 50 plus 30 plus 40 plus 20 divided by 6. So that's 210 divided by 6. So I think that's what, 35 months was the mean for that brand's fading. Now for brand B, we do the exact same process. You add up all these data values, and you also get 210. When you divide by 6, you get 35. And so we get the exact same mean, okay? But if you look at how we've plotted these values over here, you can see that one's way more spread out than the other. And that's, really what variation is calculating is the spread of your data. And there are different ways to calculate that spread, but one way is going to be calculating the variation, which we'll define here in a minute. So that's, again, variation. You should be thinking of how spread out is your data. So even though these two different tables have exactly the same mean, one is way more spread out than the other. So one way that we can calculate the spread is, I guess paint A is more variable, whereas paint B is less variable. They both have the same average length before fading, but one has a lot more variation. And so let's try to measure that spread now. So one way that you could do that is to try and measure the distance from every data point A to the mean. Okay, so let's do that real quick. So in brand A, if you take 10 minus the mean, which is 35, you're going to get negative 25. So that would be, that point right there. 60 minus 35 is going to be positive 25. And then 50 minus 20 minus 35 is 15. 30 minus 35 is negative 5. 40 minus 35 is 5. And then 20 minus 35 is negative 15. And so if you add up all those and try to calculate the average of these distances here, you end up getting 0. And it turns out that always happens. If you take your data table and you sum up x minus mu for every one of those things and add them all up, you're always going to get 0. So this measure of distance is not what we want to calculate the variation, but it's close. So we'll see how we get around this in a second, mathematically. I can't remember if we do the same thing for brand B or not, but if you do the same thing for brand B, sum all those up, take x minus mu, so x minus 35, you're going to end up getting 0 when you sum all of those up. Okay, so there's one other way to calculate the variation or spread, and that the easiest way is called the range, in which you just take the highest value in your data table minus the lowest value in your data table, and that gives you a quick and easy way to see how big the spread is. It's not terribly accurate, but it is a fast and easy check. So for brand A, if you look at the largest value was 60 and the smallest value was 10. So if you take 60 minus 10, you end up getting 50 for the range. And so that does indicate that this is more spread out than brand B, because for brand B, the largest value is 45 and the smallest value is 25? So 45 minus 25 is 20. So there the range is only 20 versus 50. But the reason why this isn't terribly accurate is if you were to throw in 2 more data values for brand B, one being 10 and one being 60, then you would have a data set that has the exact same spread as the brand A, but most of the Bs are more centrally located. So the range is not really picking up on that. Do you have anything to add there, Karen?
No.
Okay. Can you click to the next slide? Okay, so now we're going to calculate some different measures of variance. So the first thing is population variation is based on the difference or distance between each data value, that the distance from each data value to the mean. So the distance is called a deviation here. So that was the x minus mu was our distance or deviation. And so now what we're going to do is we're going to calculate the population variance. So if you take all the points in your population and you take x minus mu, and then you square that, okay, then that's going to end up eliminating the possibility of getting 0. So instead of getting negative 25 and positive 25 in that sample for A before, you would get positive 25 squared and plus positive 25 squared, and then you would divide by the population size to get kind of the average distance, right? So this is kind of like the idea is it's the average distance or variation for all the points in your population. So you just take x minus mu squared, you sum that up, and then you divide by n. Okay, so that is the population variance, and we give that the symbol sigma squared. And the reason for that is the sigma squared is that sigma is going to be the standard population standard deviation. And so all you do to get from sigma to sigma squared is you literally take the square root. And if you take in college algebra, you'll see that that looks a lot like the distance formula. Usually in college algebra, you have a whole bunch of points, and the distance formula would just say take x minus u squared, and then take the square root. That would be the distance from each of those xi's to mu. And all we're doing here is we're dividing by n, the size of your population. You have anything else to say there, Karen?
Nope, just that they want to try to like really commit to memory or learn that sigma squared is the symbol for variance and sigma is the symbol for standard deviation. Because a lot of times on Connect Math, like they'll just use the symbols. So you have to know what they mean, obviously.
Yeah, and I guess we should point out that they're going to be using both of these measures quite often. So this is something that's important to remember. Okay, so we're going to do a quick calculation using that example brand A that we saw on the first slide. And so again, we've already done this first step for calculating the variance and the standard deviation, and that was to calculate the x minus mu. Again, mu was 35. That was the mean of our data set. And so now if you take 10 minus 35, you're going to get negative 25. 60 minus 35 is 25, and so on. So this is that's how you populate the first column of this table. But again, we want to calculate x minus mu squared. So all you do is you take every value in this first column and you multiply it by itself. So 25 times 25 is 625. 15 times 15 is 225. Of course, 5 times 5 is 25. And then you're going to sum up all of these values. And I can't do that math that quickly in my head, but I think we have it written down here. Yeah, so the sum of all those is 1750. And then finally, what are we going to do, Karen? We're going to divide by...
We'll divide by capital N, which is the number of data values.
So we're going to divide by 6 here. So 1750 divided by 6 is about what? 291.6666. So that's 6 repeating, right? And you might be tempted to round that up to 291.7. But if you do that in Connect Math, you're going to end up getting the wrong answer, because Connect Math wants you to use that 0.666 and take it out to as many decimal points as you can. I guess Karen also mentioned that when we're in this chapter, we're always going out one decimal place further than our original data point. So since we didn't have any decimal places, when we write the answer, we want to write 291.7. And I think for variance, it's okay to write 291.7, right? It's just when they go to calculate the standard deviation, that's when you want to use the 0.666.
Correct. So yes, they can definitely put for their final answer for the variance 291.7, but then when they go to calculate standard deviation, they want to use the exact value, which was the 291.6 repeating.
Right. So I guess this is a good time to mention that we're not huge fans of Connect Math, but we have to use it this semester. We like it less than they will like it. And we're just not fans, but it's the best we have, at least for this semester. So let's just try to power through, and we'll be understanding if there's some discrepancies with decimal points and stuff. Okay, so that was the variance. That's the sigma squared. And then to take that value and to get the standard deviation, which is sigma, all you do is you take the square root. But it's important to write 291.6666 repeating, and then take the square root, because you don't want to have round off error when you're getting this value. So when you do that, you get about 17.1. And again, you would write this in Connect Math as just 17.1 is the standard deviation. Okay, and I think Karen's going to show us how to do this on the calculator on the next slide.